Hello guys, and welcome to our video where we talk about high altitude vacuum testing of electrical connectors and components. So really quick, let us tell you about us guys. We are Senatron and we are an engineering excellence company. We're located in Salt Lake City, Utah. We've been in business since 2008 and we're experts in vacuum science and technology, custom fabrication, especially polymer fabrication, and robustly designed and quality engineered systems. We develop, we design, and we manufacture vacuum systems, and that includes laboratory equipment, leak testing systems, and instrumentation. And we also make high altitude vacuum testing systems of electrical components, connectors, circuit boards, and etc. And everything is envisioned, designed, and made in the USA. So before I forget, please like this video and subscribe to our channel. Alright, so let's talk about the design requirements that we had for this particular project. So we were testing for electrical discharge or arcing at a certain altitude, and we were testing proprietary connectors and cables that our customer gave us, and we had to make their connector work with our vacuum chamber. And the altitude requirements for connectors and cables were 100,000 feet, and that corresponds to about 30.5 kilometers, which is a pressure of about 8.36 Torr, absolute. And some of the cables were up to 48 inches long, so we had to accommodate and build a chamber that would accommodate this long of a cable. Of course, our customer also required a complete turnkey system where we provided a vacuum pump, we provided vacuum connection hardware, and we provided a digital vacuum gauge because a dial vacuum gauge just didn't have the accuracy as well as the resolution to display in 8.36 Torr. So let's talk about Paschen's law, and I hope I'm pronouncing this right, and why it is important in this particular application. So the Paschen's law describes the relationship between the breakdown voltage, also known as electric discharge, the gas pressure, and the distance between two electrodes. What it means is that, and if you look at this graph where the breakdown voltage or electric discharge voltage is on the y-axis, and the distance as well as the pressure on the x-axis. So based on this graph, you can easily see that as the distance decreases, the discharge voltage will decrease as well. Likewise, as the pressure decreases and the distance stays the same, the discharge voltage will decrease as well. Now, why is this important? Well, because at a higher altitude, as you go up in altitude, the pressure will decrease. And as the pressure decreases, the discharge voltage between the two electrodes will also decrease. Okay, so this means that at a higher altitude, it will take less voltage to create a electric discharge and therefore short circuit your connectors, your electrical circuits and whatnot. So it is very important if you are designing aerospace components to actually test for a higher altitude, to essentially take your circuit board, take your connector, and actually decrease the pressure to simulate the effects of a higher altitude as well as the lower pressure, and test to make sure that there is no electric discharge, because if there is, then you short circuit and you fry essentially your connector and components. So let's talk about, and we had another design challenge, or better to say we had another design opportunity. So this is one of example of the connectors that our customer provided to us and that we used. And another challenge was, you can kind of see the tabs here. There were 3 tabs on this connector, and you can kind of see it right here as well. And we had to seal on the tab side. So this connector is already hermetically sealed, meaning that there's no air. This is airtight from outside and inside. But we had to make this connector work with our vacuum chamber, meaning that we had to seal the tap side. And so what we had to do is we had to seal it on this side, which means that we designed a plate and we designed a O-ring groove, and you can kind of see that there is 3 little clearances on this clearance hole where the connector would go in, and then we would sandwich the flange of this connector against this O-ring, and this O-ring will compress against this O-ring groove into the seat. And this worked out really well. Now, we had to make it thin enough so that the other connector that connects to this piece would be able to grab on and then twist, because this was a twist-on connector. If this plate was too thick, then you wouldn't be able to insert this connector and grab and twist. So it had to be thin enough. This means that it disqualified acrylic, and we had to use a metallic plate. And another challenge was to actually compress it. So we had to compress it from the outside. And what we came up with is we came up with this plate here that essentially pushed and sandwiched the O-ring, from this previous slide, this O-ring against this surface, and as well as against the flange of this connector. So from the inside it looked this way. You remember with regards to the connector, they had to actually come in and twist and then lock. And then from the outside we had this type of a connector. And so essentially this is what we came up with, and it worked really well. And the final system, or the final vacuum system, was essentially we provided them with a cylindrical vacuum chamber that would accommodate their longest cable, which was about 4 feet long. We also provided them with a vacuum pump and a venting valve, a digital vacuum gauge, as well as a vacuum valve. And this was pretty much our design. And this worked really well. They were able to change their connectors as well as their cables and test them at higher altitude. So this worked out really well. All right, well, thank you guys for watching. And if you guys have any questions or comments or concerns, please post them in the comment section below. I will go ahead and link to the website and more, where you can see more photos of this system and design. And please, of course, don't forget to like this video and subscribe to our channel. And if there's anything that we can do, feel free to contact us. And thank you very much for watching, and you guys have a wonderful day. Bye.